Notes2.5. It's on slope. So we're going to be looking at, remember how we were talking about slanted lines? Now we're going to look at how steep are those lines. So that's what we're going to be checking out. So the slope is a numerical measure of the steepness of a line. And so there's a lot of other numerical measures of things, like temperature is a numerical measure. If I told you today it's going to be 23 degrees Fahrenheit, you'd be like, 23 degrees? Are you kidding? In Bakersfield? It's going to be freezing, freezing cold. I'm going to have to wear my jacket. And so just that number, 23, tells you freezing cold. I need to wear my jacket. And so that number starts to mean something to you. Whereas if I told you, I heard today's going to be 97 degrees, you'd be like, oh, it's going to be pretty warm. I don't need a coat for sure, right? And so anyway, so that's kind of a numerical measure. So if you work with slope and you start noticing, work with it quite a bit, you'll get where you can tell the steepness of a line by looking at it. Slope is defined to be the vertical change divided by the horizontal change. Another way of saying that is rise over run. Another way of saying that is the change in y over the change in x. So the rise, the y's are the up and the down, and that's your rise. That's your vertical change, your up and your down. Your horizontal is your x's, left and right change, and that's called your run, your left and right change. And so over here we have our change, which is our run, so it's our left and right change, and our rise, which is our up and down change. And slope is a division between those things. Always rise is in the numerator and run is in the denominator, doesn't switch. And then another way of, and this is the slope formula, if you will, and this is if you're given 2 points. And so this is the slope formula given 2 ordered pairs, 2 points. And those 2 ordered pairs are labeled x1, y1, and x2, that's an x, it looks like it does not look like an x, x2, y2. So this is the x coordinate of point 1, this is the y coordinate of point 1. So these ones, the little subscript ones, are just telling people this is point 1 as a label, and this is point 2 as a label, is all that tells people. M is the variable used for slope, and I just put a remark about possibly why M was chosen, because this whole Cartesian coordinate system was come up with a guy named René Descartes, and he was French, and the French word to climb, which slope kind of goes with climbing, right, starts with an M. And it's said that Descartes never used M for slope, but his followers did. There's evidence that his followers did. So anyway, so it's possibly where the M in slope came from. Definitely, if I would have been the person naming slope's variable, I would have used S, right? S for slope. But anyway, I wasn't the person that got to name it. So, so M is what is used. And they start us off with, they're wanting us to find the slope given a graph of a line. So they're going to give us a graph, and they're wanting us, just to get the idea of slope, they're wanting us to use rise and run. All of these are kind of going together with rise and run to come up with the slope. And it's a process about counting. And so all you have to do is be able to count to be able to find it. And you can start counting your rise first, or you can start counting your run first. It is a little easier on counting if you start with the point on your left, so that's my choice. I was taught to count by my algebra teacher, Mr. Heater, the run first, so I count the run first, and then I count the rise second. But it matters not, and I'll show you that how it does not matter. at all, which one you start counting first. Okay, so we're going to give a try to these problems. So the slope is the rise over the run. And it's a little easier if you start with the point that's on the left. So this point is left of that point. And then I'm going to count over, and I'm going to walk from this point here, it's my plan, to that point there. I'm going to walk there and I'm going to count. So as I count this way, I count 1, right? So there I counted 1. And then I get here and I count 2. And now I notice that I am lined up to go right up to that point. So I only can walk horizontally and vertically. And I was taught to walk your run first, but that was what I was taught. It doesn't matter, and I'm going to show you that it doesn't matter at all. And so because it doesn't matter, I get to choose, right? So 2, that's my run. And then when I count here, so I'm here now, and I'm going to walk 1, 2, 3, I'm going up, 4, 5, 6, I'm there. So 6 is my rise, right? And so my slope, you reduce it, is 3. And slope can be a fraction, or slope can be a reduced whole number, like this one is a whole number. And so this one is a whole number, and typically you would just write that the slope is 3. Now I want to show you that it would not matter what you started counting first. So you could have started here, and you could said that I count my rise first. So you would have counted 1, 2, 3, 4, 5, 6, and then you would have come and wrote down 6 for your rise. Then you would have count here 1, 2, and I'm going in the positive direction, 2 for my run. And then 6 divided by 2 is 3. So it makes no difference whatsoever which one you count first. Now I can't help myself, but I have to show you that it doesn't matter if you start with the point on the left or on the right, but it does make it a little more difficult if you start with the point on the right. So if you're up for a challenge and you're wanting it to be a little more difficult because you don't like your math to be so easy, then you certainly could do that. And so I'm going to show you that you would get overall the same answer. So if I started here, and let's say that I decided to count my run first, so I would be counting here 1, 2. But I've gone in this direction, and that is the negative direction for x, right? Moving in the negative direction, moving backwards. So this is, the run here is -2. And then I'm going to go down to this point, so I'm going to be going down, and that's the negative direction for y. So I'm going to count 1, 2, 3, 4, 5, 6. So that's -6. And -6 divided by -2 is +3. So you get the same answer, but it's trickier because people forget to do the negative. So since they forget to do the negative, then they get the wrong answer. So, and you can see that if I counted my rise first, I'd be going down, and I would get the same answer. So you could certainly see that. Okay, so we're going to try this one over here, number 24. The slope is the rise divided by the run. And we're going to count over to it. And I was taught to count the point on the left first. So this point, if I'm looking, for my nice points, looking from the left, like you read, it would be the first one I came across. And coincidentally, 1, 2, the run is 2 on this one. And I told myself that I was going to go and change this. And it's not until I'm looking at it right now that I notice I didn't. So the exciting part is that you'll see some in the book that are different. So I was going in the direction positive for the run, right? And now to get to this point down here, I'm going to have to go in the negative direction for the rise. So I'm going to get a negative in there. And then I'm going to count 1, 2, 3, 4. So the slope is -2. And so this was going uphill. If you were an ant, ants walk on lines left to right. Uphill is positive slope. downhill is negative slope. And this one here, you can see that this is a horizontal line. And so I want to show you that the rise and the run makes sense on it too. Rise and the run. They didn't put 2 nice points for me I didn't put 2 nice points because I didn't know how to make the points on there, but I'm going to put a point here. It's arbitrary, and a point here. It's arbitrary. Any 2 points on the line would give you the same answer. And so this one is the leftmost point, and so that's where I'm going to start. I was taught to start with the leftmost point, and I'm going to walk to that point there. So when I do, I'm walking over 1, 2, 3, 4, 5, right? So 1, 2, it's counting, 3, 4, 5. So my run is 5. And then how far am I going to go up so that I hit the other point, or go down so I hit the other point? Well, don't move at all. You're already hitting the other point, so don't move any. My rise is 0. And then 0 divided by 5 is 0. And I'll tell you that every horizontal line has slope equal to 0. Every single one of them. So if you notice the line is horizontal, you don't have to count it like I just did. You can say the slope is 0. If you forget that the slope is 0, well, you can count it just like I just did and reason it out that it is 0. Now this is a vertical line, as you can tell by looking at it. So the rise over the run. And I'm going to pick just 2 arbitrary points on the line. This one, there were other points that you could have used, but since they gave me the nice points, and I want to make sure that I use nice points, but there's some, I just drew in 2 more nice points and would have given you the same answer if you would have used that. I won't probably be able to help myself. I'll probably have to go back and show you that it does give the same answer. So any 2 points on the line should give you the same answer. So I'm going to start here. There's not a point that's a leftmost point. So I'm going to call this my starting point because they're tied, right? And this is going to be my end point. And so how far do I move left or right so that I can line up with that point there? Well, none. 0. My run is 0. My rise, though, is 1, 2, 3. So my slope is 3 over 0. And if you do 3 over 0 on your calculator will tell you math error is what your calculator will tell you, just like my calculator just said. And there's a word, a vocabulary word that goes with that, and that word is undefined. So, and I'll tell you that every vertical line has undefined slope. Every single one. Your book uses the word no slope. Most books, some books do and some books don't. And so use the word no slope. No slope goes with a vertical line. No slope does not go with a horizontal line. So some people think, well, I won't have to remember which one's which. I'll just call them both no slope. And that's not correct. This is slope 0, goes with a horizontal line. If you say that a horizontal line has no slope, then you're incorrect. So no slope goes only with a vertical line, is all that it goes with. Now, I couldn't help myself. If I was walking, and I'm going to walk from this point all the way to this point, and I just want to show you that you would get the same answer. It doesn't matter what points you use, as long as they're good points on the line. And so this is a nice point. I'm going to walk all the way to the end. So I would walk over 1, 2, 3, one more, 4, right? So my slope, rise over run, my run is 4. And then I'm going to go down, so I know it's negative. 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Negative 8 over 4 is negative 2. So it shouldn't matter, you know, if they give you nice points, then you should go between those nice points. Because if I pick another point and it's not really on a corner, I just think it's on a corner, then because, you know, your line kind of gets a little bit of thickness going on it. But if you do really get a point on the graph, it should be the same. Now, this is just something I got off the internet, and I think it's really lovely. But when it's going uphill, it has positive slope. When it's going downhill, it has negative slope. And you need to find the numerical value for both of these. And that one too. You need to find the numerical value. So it's not good enough just to say it has negative slope, unless that's all they're asking you. Is it positive or is it negative? Usually they're asking you for the numerical value, like 3. It was the numerical value. -2 was the numerical value here. It could be a fraction as well if it doesn't reduce. Those two just happen to reduce. Horizontal lines have slope 0. That's the numerical value of the slope, 0. And vertical lines are slope undefined, and they don't have a numerical value that goes with their slope. Okay. So another strategy for finding the slope, it is given 2 points on the line. You can use the slope formula. And so the first thing that you do is you label your 2 points. So you identify the 2 points from the graph if they're on the graph or if they've given them to you. And then you label them x1, y1, x2, y2. Doesn't matter which one is the point 1 and which one's point 2. You get the same answer. It all comes out in the wash. And then you do this formula. So we're going to do that. This is my computer got accidentally in symbol. And so this was and so it was doing Greek letters for A and D. And so those were the points. And I noticed it and I was going to change it, but then I thought it was funny, so I didn't. And so that's how that goes. I usually label the one that's first, the ones, and the one that's second's, the twos. But that's me, and you could say that you always do it backwards of that because you're you know, individual rights and all that. It'll all be the same. So I need to make sure that when I plug these points in, that I don't make any arithmetic mistakes, and I think putting parentheses is kind of a nice way of not doing that. So y2 is -1, so right here is -1. And then y1 is 3. I already got the form of it, all I have to do is fill in, right? x2 is 3. x1 is -3. And then all I have to do is do the arithmetic, and then I will know the slope. So in the numerator, I have -1 subtract 3, that's -4. And in the denominator, I have 3 plus, right? Subtract of a negative is a plus. I have 3 plus 3, which is 6. So my slope is -2/3. You would reduce your fraction and leave it as a fraction. And so you wouldn't write it as a decimal, and you would not, I can't remember what I was going to say. I don't know. And then this is Mr. Slope Guy. I don't know. Somebody on the internet did it. I think it's kind of cute. It has positive slope. It has negative slope. It has slope undefined, right? U for undefined. And slope 0. And so, I don't know. Kind of funny. Here they're asking me to do something different. They're asking me to graph the line given the slope and given a point. And the point that they've given me here is the y-intercept. They say B is the y-intercept. And so they could have given me any point, and they could have given it as an ordered pair, but they said that they're giving me the y-intercept. So how you do that is you start by plotting whatever point they gave you. So the point they gave me was the y-intercept. So they said that B is going to stand for the y-intercept. So this is the y-intercept equals 4. That's what they said. Y-intercept is B. That's common to call the y-intercept 4. So here's the y-axis, and I'm going to go here on the y-axis, 1, 2, 3, 4, and at 4 I'm going to make a dot. Then in order to get another point on the graph, you're going to use your slope. and your slope is driving directions or walking directions, you're going to count over to it. And if it's a negative, you need to associate that negative either with the numerator or with the denominator. And I like to put it in the numerator. And where this came from is when we first started out, I told you guys that if you had negative a over b, you could write that as negative of a over b, and that your book always would do that, right? And this time I have this, but really want to go back to that. So I'm going to write my slope as negative 3 over 5. So my slope, remember, is my rise over my run. So I'm going to count my run, and then I'm going to count my rise. So I'm going to be here on this point, and I'm going to count my run. 1, 2, 3, 4, 5. The only reason I'm writing the numbers there is so that you can see that I counted. And so I normally wouldn't write the numbers there. I would normally count 1, 2, 3, 4, 5, right? And then my rise is negative, so that means go down. So this meant go in the positive direction. So I'm going to go down 1 because it's negative, 2, 3. And that's where my next dot is going to be. That is right there on the 3. And now I have 2 points on my line, and I can draw my line. Now, you would get the same line, and I want to show you that because also you probably remember that if you have a over b, negative b, that was equal to negative a over b as well. So you could put the negative in the denominator. In our case, our slope would then be 3 over negative 5. And I just want to show you that you would get the same answer. The line is the answer, which I haven't drawn yet. But you would start from this point, and I was taught to count my run first. And this is run in the negative direction, 5. 1, 2, 3, 4, 5. And then go up 3. 1, 2, 3. And you notice that the 3 points are all 3 on the same line. So if I was to draw this line just through those 2 points, it would include that one, right? Or if I was to draw through here, I would include that. Now, I don't live in a very wild place, but today there's been a raccoon in my backyard going around. And so I don't know what a person does about a raccoon in their backyard. I think just let it go is what I'm going to do. But anyway, so there's your story. So I said draw a line through the 2 points because usually I wouldn't get all 3 of them. It wouldn't be necessary. But I just wanted to show you that whichever 2 you get would be good. And so I can't help myself but watching this crazy raccoon. So they want me to graph this line, and then they want me to name the slope and the y-intercept by looking at the graph because they are trying to prove a point. And if you've had algebra before, you already know what point they're trying to prove. But we're going to give a try to it. So what they're wanting me to do is graph the line the way they showed me to do in section 2.3, which is to pick points. So my favorite point to pick when it's solved for y is 0. And when I do the arithmetic, y equals negative 1/2 times 0 minus 2. So when I do that arithmetic, this is 0, and I get y is negative 2. And because it's got a fraction, the best thing to do is to use the multiples for x. Use multiples of 2, the denominator. The multiples of 2 are 2, 4, 6, 8, on it goes. Also 0, which I've already used, it's my favorite point, and negative 2 and negative 4, etc., right? And I'd like to stay on my grid over there. And so probably the next point to choose would be 2, right? Because it's just small, positive, lovely. So we get y equals negative 1/2, and in for x, parentheses, I'm going to put 2 minus 2, and I'm going to do the arithmetic there. And when I do, the 2's cancel out and give me negative 1 minus 2, which is negative 3. So that's my value for y. And then I think I'm going to choose -2, but you choose whatever makes, whatever floats your boat would be great. You should choose a multiple of 2 though, because you should not purposely choose fractions. If you do, then you're probably going to make more errors than you like, because people don't work real well with fractions. So here I'm going to get, even though they're lovely, kind, and friendly, fractions are friendly. So this is +1 minus 2 is -1. And yeah, if you're having trouble with your arithmetic, use your calculator, right? And let it help you. And here too, right? And here too, if you want. Great. So I'm going to plot those points over 0 down 2, over 2 down 3, over -2 down 1. And so you can see that they're on the same straight line. So this is what they asked me to do in the first step. Draw the line. So they wanted me to graph the line the way that I have been, and then they wanted me to come up with a slope by looking, and the y-intercept, by looking at the line. So I know that the slope is the rise divided by the run, right? And I have been taught to use nice points that you have on the line. So this is a nice point, and I was taught to use as your starting point the point that you have that is the leftmost point. So this is the leftmost point, and walk to any of the other points that you have. I'm going to walk to that one, what the heck. And I was taught to count the run first. 1, 2, 3, 4. And if you're saying by counting over to that one, you're going to have to reduce, you're right. 1, 2, and it's down, right? So -2. So this is -1/2. But I didn't care. I wanted to count to that point. So I did 1, 2, and it was down, right? So it was negative. And so now they also wanted me to, by looking at the graph, look at the y-intercept. And the y-intercept is right here, which is -2. Now I can look at the graph and tell people what the x-intercept is. It's right there. Looks like it's part way in between -1, -2, -3, part way in between -3 and -4, right? They didn't ask me to find that, but it turns out that the x-intercept is not so special of a guy, but the y-intercept is a real special guy. And so now I have the slope, -1/2, and I have the y-intercept, 2. And they're wanting to know, when you look at the equation, when it's solved for y, do you notice the -1/2 there? And if you're saying, yeah, it's right there, it's the coefficient of x, put your finger on x, there it is, you're right. And do you notice the -2, the y-intercept right there? Well, it's not a coincidence, and that those points, the slope and the y-intercept, are just there for free when the equation is solved for y. They're just wanting you to notice that, is all that they were wanting you to do. And so we're going to have some stories, more stories. So this is just reminders. So we already knew that that the equation of a vertical line is x equals some number, and that's how I write it is, and I told you your book used a. And the horizontal line, and I got this off the internet, and so I make a lot of boo-boos myself, but they made a boo-boo there, and so I don't know how to fix it other than to cross it out and say what they meant horizontal, is y equals a number. And remember, they use b for the y-intercept. There's b for the y-intercept. What are they using for the x-intercept? A is what they're using there. But b equals, so y equals a number is the equation of a horizontal line. Now, some other things that we knew about a horizontal line. We knew that its slope was 0. We knew that the slope on a vertical line was undefined. So this is just a review of things we already knew, right? And they're reviewing the things they already know because they're going to add another story that we know. They say slanted lines, those are equations that have x and y in them, where vertical lines only have x in them, and horizontal lines only have y in them. Slanted lines have both x and y in them, and you can find the slope by solving the equation for y, and the coefficient of x is the slope. And when you let x equals 0, that's how you find the y-intercept. 0 times m is gone, and y equals b is the y-intercept. And so remember how we found the y-intercept. We let x equal 0, and that wipes that part out. So people say it's just that, and you're right, it's just that. But the reason it is that is because how you find it is you let x equal 0. So that's what wipes that out. And so remember that from, what section was that? Meet the intercepts, 2.3, right? How you find the y-intercept is let the other guy, which is x, be 0. So anyway, then they just kind of review that just to see really quickly. And so they say, here's an equation, and they just say, what's the slope? And you should be able to do it like this, right, is what they're saying. So you should be looking at this, and the thought that should go, so this is the thinking that you would do is on this first one, the thinking that you would do is that you would be like, vertical, it's vertical. And I know the slope of all vertical lines, it's undefined. Every single one of them. Another way of writing that is no slope, and your book does write no slope. So most books put undefined, many books put no slope. Most books do interchangeable, and our book does a little interchangeable, but I notice the answers in the back of the book say no slope, so I want to make sure that I'm adding that word. And then my thought here, this is what I would be thinking here, is, oh, this one's horizontal. So the slope is 0. And then this one right here, because it has x and y in it, I know it's slanted. And so my thought, when someone asks me for the slope, is solve for y. When you have both x and y, which I am solve for. And then the slope is the coefficient, number coefficient of x. So put your finger on x, and the slope is now looking at you, -2. The slope is -2. And so those are what you would be thinking. One last problem, and you're probably saying, really, one last problem? I can stand no more. But you probably have seen rodent signs that say what the grade is. And the grade is the slope of the road. So what does the 7% mean? It's the slope of the road. And remember that percent means per 100. So that means the road drops 7 feet vertically for every 100 feet horizontally. And so that 7%, remember, written as a fraction, is 7 over 100. And so the run is 100. The rise is the drop in the road if you're going downhill. If you're going uphill, the rise in the road is 7 feet. So the slope is the steepness of the line, and usually they call it the grade whenever they're going to call it as a percentage. So this is an example. They only have one in your book, so I didn't want to use it. So I used this example from Yellowstone when I was visiting Yellowstone. At one point, Yellowstone's Beartooth Highway rises 315 feet over a horizontal distance of 4,500 feet. Find the grade of the road. Note, the grade of the road is a slope written as a percent. So the slope is the rise over the run. If you want to write this as a percent, that's a fraction. All you have to do is times it by 100%. So I wanted to write that differently, and then I didn't. So the grade is the slope times 100%. And the slope is the rise over the run. So times 100%. That's what the grade is. Okay. In our case, they talk about the rise right here, 315 feet. Then they talk about the horizontal change, right, of 4,500 feet. But I just want to remind you that that was way back, right? Horizontal change is another word for the run, right? And so they're now using that other word, the horizontal distance or the horizontal change, 4,500 feet. That's the run. And then times 100% to turn it into a percent. Feet divided by feet cancel out. And I'm going to put these numbers in my calculator, and then that will be the percent. I'm not putting the percent sign in my calculator. So I'm going to have in my calculator here 315 divided by 4,500 and then times 100. And coincidentally, it's 7, which is this picture because they came from the same place. The example in my example in this picture came from the same place. So 7% is the grade of the road. Okay, so we did a lovely job on those, and that is the end of 2.5.